Hello, class. Today we'll be looking at something very, very interesting. And the topic is formula and equations. Okay, the objective for today's lesson is you should be able to, by the end of the lesson, state the charge of the ions of each of the elements we have on the periodic table. You should also be able to state the symbols and the charge of some polyatoms, okay? Otherwise known as radicals. And then finally, if time permits us, we'll look at writing of the formula of a compound, okay? Now, why learn how to write a formula? The chemists, we use formula a lot, okay? It makes us recognize a compound easily, and it speaks volume about some of the constituents of a particular compound. Okay, you're familiar with elements and their symbols. So today we'll be using our periodic table as we go on to the class. Okay, so basically we'll be looking at some regular elements we have, and their symbols. You'll be familiar with element like aluminium, lead, argon. They are all in your periodic table. Okay, and we have some cases where we have molecules. Okay, molecules are neutral compounds. They can be diatomic, they can be monoatomic, they can be polyatomic or tetraatomic. Okay, we've done that in the last class, okay, where we gave examples of gases that are diatomic, like hydrogen, oxygen, chlorine, fluorine, and other members of the group 7 elements. Okay, so we also went as far as giving example of tetraatomic, like phosphorus molecule, and polyatomic, like sulfur. Okay, sulfur has about 8 atoms in one molecule, so it's regarded as polyatomic. So having gotten familiar with the symbols, of most of the elements, we go straight into compounds. Okay, we have some common compounds we'll be looking at today. Okay, like carbon dioxide. Why do we call carbon dioxide carbon dioxide? Okay, we have 2 oxide groups in that compound, okay, and 1 carbon. And that's where it derived its name, carbon dioxide, from. We also have carbon monoxide. Carbon monoxide, on the other hand, has just 1 oxygen, okay, in this compound, and that is why we use the word mono. Okay, we use the word mono for that. Mono stands for 1. So for di, we say stands for 2. Okay, that is for carbon dioxide. So we also have some compounds that their name does not give you a clue of what the formula would be. So it's not every compound that, it's not every name of a compound that actually give you a clue of what the formula would be. Take, for example, ammonia. When you hear the name ammonia, there is no element that comes to mind, okay? There's no elements, okay. Ammonia, what constitutes ammonia? Actually, the formula is NH3, okay? Formula is NH3. So there is nothing to give a hint or clue of what the name or the formula would be. But you're expected to know some of these compounds. There are very few of them, so it's good you know about them. Other examples like cyanide, okay, which is just a compound containing carbon and nitrogen. We have methane, okay, which is an organic compound. Methane, which is an organic compound. Methane is a compound that has carbon and 4 atoms of hydrogen. Okay, so these are common compounds you need to familiarize yourself with. Like water, the common one, water. You know, the name water does not also give you a hint or clue of what element constitutes it. Okay, but we all know and we're all familiar with the formula of water, which is H2O. Okay, so as you already know, compounds are made from um, two or more elements coming together, chemically bonded together, gives you a compound. Now we'll categorize these compounds into two. We have what we call the ionic compounds and we have the covalent ones. So the covalent ones basically are molecules, okay? Organic compounds, most of them are covalent in nature. But the vast majority of the compounds we have in the world today are ionic. Okay, so today, for the sake of time, we'll focus majorly on the ionic compounds. So probably when we meet next week, we'll look at covalent compounds. So the first thing that we need to learn to be able to write the formula of a compound is to get the charges of the ions, okay, of the elements that constitute that compound. So the trick is very simple. When you have group 1 metals, okay, from your periodic table, you can look at your periodic table. You'll see that the first member of group 1 is lithium, then followed by sodium and potassium. And as you go down to francium, okay, every member of this group, the fact that they belong to group 1 will have the same charge. So their charge is +1. Okay, their charge is +1. Same principle applies to group 2. Okay, group 2 metals, the first member there is beryllium, and then you have your magnesium, calcium, and down to barium and the likes. They all have the charge +2, as you can see on the left side of the screen. Okay, they all have the charge +2. Same principle applies to group 3, where we have aluminium. So the charge of aluminium is also +3. Okay, so this principle applies to all the metals. However, we have some special metals that we need to look out for, okay, that we need to familiarize ourselves with. The first one here is ammonium. You know, ammonium is NH4 plus. So we'll be looking at most of these NH4. Okay, it has a charge of plus. Okay, so this is ammonium. We have copper. Copper is a metal, like we know, but it's a transition metal. Okay, these are metals you find in between group 2 and group 3 on your periodic table. Okay, they have this variable oxidation state. We have copper 1, we have copper 2, we have iron 2, we have iron 3, as you can see on the left side of the screen. We also have lead 2. We also have silver. So you have to familiarize yourself with the charges of these ions if you want to be good in writing the formula of a compound. Okay. I used to give a trick. The precious ones like silver and gold, they have the charge +1, just plus. Okay, while zinc, copper, and lead and the likes, they have the charge +2. Even iron is +2. Okay, that is the easiest way to memorize this. The only difference is iron can either be +3 or +2, but in most cases it's +2, except if otherwise stated as +3. Okay, so we move on to the non-metals. The non-metals, on the other hand, we'll start from group 5, 6, and 7. So you would recall when we were treating valency, and we said the valency of group 5 compounds, elements are basically 3. Okay, so their charge will be -3. Same principle applies to group 6. Okay, their charge is -2, that's -2. The reason is they require 2 electrons to achieve octet structure, okay, to be stable. The same principle applies to 7. So if 6 require 2 to reach octet, 7 will require 1 to reach octet. Okay, you would recall all that. So we'll be applying all these into the writing of formulas. Okay, we have others that you need to really familiarize yourself with. Carbonate, sulfate, hydroxide, nitrate. Very important. Take note of that. Now, how do we get the charge of these special polyatoms? Okay, how do we get the charge? In case you forget, okay, in case you forget, it's very easy. Let's pick carbonate, for example. Carbonate is CO3. Okay, the trick is the charge for oxygen is always -2, as you can see, towards group 6. Okay, let me point that. Okay, as you can see here, you can see the charge of oxygen there is 2 minus. So you have to take note of that. So it's very important. So whenever you see oxygen in a compound, the charge is always -2, except for peroxide. Okay, so now if this is -2, that is -2. We have 3 atoms of oxygen here. Okay, who makes it 3? And you know, -2 times 3 is -6. And then you come here and you check the group carbon belongs to. Carbon actually belongs to group 4. You bring that group down here. And then you say 4 minus 6. That should give you 2 minus. That is -2. This principle works perfectly. You can do the same for nitrates. Okay, nitrates has the formula NO3. How do we remember the charge in case we have forgotten? Same principle applies. Since we have 3 atoms of oxygen, that will be -2, the charge for oxygen, bracket 3. Okay, and then nitrogen is in what group on the periodic table? Oh, that's great. That is group 5. Okay, and then 5 minus 6 is actually -1. So that gives us the charge minus for these polyatoms. Okay, it's expedient you know this. So quickly, let's give a formula to a compound. Okay, because of time, let's look at a good example will be calcium nitrate. Okay, calcium nitrate. Okay, so calcium nitrate, calcium has a symbol Ca. Okay, and the group calcium belongs to is group 2. Since it's a metal, it has a charge 2 plus. Okay, and then nitrate on the other hand, we know has the charge 1. Okay, that is -1. Okay, that's 1. That is -1. So when you want to write formula, you ignore charges. I mean, you ignore the sign on the charge. You don't need to bother yourself. So instead of writing 1 minus, I just write 1. Okay, and then the next thing to do is to check. Calcium actually is deficient of 2 electrons, while nitrate has gained 1. Okay, so what this means is if I want to balance these charges to get 0, because the net sum of any compound must be equal to 0. If you have +2 here, then you should have -2 on the other hand. But in this case, you have -1. So what do I do mathematically to make this nitrate to cancel out this 2 plus here for calcium? Okay, you would agree with me that if I make this into 2, as a group. So that way, -1 times the 2 down here becomes -2. Okay, so +2 -2, that gives you 0. So that is the formula for this compound. Okay, the formula then becomes Ca, open bracket, NO3, okay, then 2. When you're done with this, you don't need to write the charges anymore. Okay. Another way you can go about this is, like I said before, just forget about the sign. You have 1 on this side and you have 2 on this side. So just exchange their charges. Okay. 1 goes to calcium and then 2 comes to nitrate. We call that crisscross. Okay. Call that crisscross. So like exchanging the charges. So when you do that, the charges becomes the subscripts, okay, of that element. So calcium will have subscript 1. There's no need writing 1, okay, and then NO3, the nitrate will take the 2 from calcium, and that becomes this. You can see either ways you get the same answer. Okay, this is how you write the formula of a compound. Let's take one final example, which is calcium chloride. Calcium chloride. Okay. Now, calcium belongs to group 2, so still 2+. Chlorine, on the other hand, is in group 7, so that will be -1. So to make it equal with the 2 here, such that we get -2 to cancel out the effect, we will need 2 of the 2 of the chloride ion. It's very important. We need 2 of the chloride ion to do that. In this case, you need to group the chloride ion in a bracket because this is a single ion, unlike the nitrates where you have more than 1 atoms present. Okay, so what you just do is you can just put the 2 here and you're good. Okay, indicating that, oh, though we have -1 for chlorine, but we have 2 of that. Okay, we have 2 of the chlorine. So adding that up to this will eventually give us 0. That will be +2 -1 -1. Okay, so we have other examples, as you can see on the screen. Okay, remember the crisscrossing method also can also be adopted here. This +2 can go to chlorine, and the 1 for chlorine comes to calcium. You still get the formula CaCl2. So we have other examples. If you look at the left part of the screen, you see other examples here. So I'll give you some exercises to try out, and then we will look at it together and see whether you actually did well. If you do well, then we can advance to the other phase of this topic. So I'm going to give you a few minutes to look at what we have here. Okay, question 2 precisely. You should be able to give me all the formulas for these names we have here. Okay, it's nice having this class with you, and it's been a fruitful and a joyful moment. I would like to draw the curtain here today. So when we meet next week, we will check how well you did your homework, and if there is any need to correct 1 or 2 things, then we'll do that in the next class. So have a great day. Bye.